These questions ask us to use identities to simplify the expression, and like the instructions say, there are more than one form of the correct answer, but really what you're looking for is to get this down to a single expression or to the smallest, most simple expression that you can. So I'm going to go through some of the even ones here and try and help make them a little bit easier for you. So starting with something like 28, oops, sorry. You've got cosine beta times tan beta. So this one I should just be able to do pretty quickly. If you keep cosine beta, but then use your identity where you change tangent to sine over cosine, that's always a good strategy to change to sines and cosines. You'll usually be able to simplify whatever expression you're trying to simplify. So I've got sine beta over cosine beta, and I should be able to cancel out my cosines, and I'm just left with sine beta. So now that I'm down to a single expression, that's sort of your indicator that you're done. So you should be able to say, yeah, you know what, sine beta is a nice simplified version of my original. So that's an example there. For something like 30, we can go ahead and do that. So I'll just come down here. So secant squared times 1 minus sine squared. Secant squared times 1 minus sine squared. Now again, you see something like a 1 and a sine squared, or a 1 and a cosine squared, or a 1 and any trig function squared. And immediately what we should be thinking is our Pythagorean identities. So what I'm going to do is rearrange one of my Pythagorean identities so that it looks like what I have here. So again, if I subtract sine squared from both sides, I end up with 1 minus sine squared is equal to cosine squared. So I'm going to use that substitution, and that means that this expression here is going to be secant squared, and then 1 minus sine squared is cosine squared. So the good thing is that I know cosine is 1 over secant, or secant is 1 over cosine. So I'm looking down here at my reciprocal formula that I want to use, and I'm going to go ahead and change secant to 1 over cosine. So I've got secant squared, so I'm going to change that to 1 over cosine squared times cosine squared. Now again, cosine on the top, cosine on the bottom, those are going to cancel out, and you're just left with 1. So this expression actually just simplifies to 1. So you can see why something like this might be useful, because we don't have to keep a clunky trig expression when it's actually just equal to the number 1. So for 32, I've got cosecant theta over secant theta, and again, I'm going to look at my reciprocal formulas down here and try and make some substitutions. So I always say try and change it to sine and cosine, and it's going to make simplifying these a little bit easier. So because secant is 1 over cosine, I'm going to take this secant and just move it up to the numerator, because, I want to just make this a little bit clearer, just in case you can't see really what we're talking about here. This expression is the same thing as cosecant theta over 1 times 1 over secant theta, right? When you have something in the denominator, you can really just consider it as you're multiplying by 1 over that number. So once it's broken up like this, you might find it a little bit easier to take cosecant, do my reciprocal, and have that be 1 over sine theta, and then secant is cosine of theta over 1. So once you have this and you simplify it, you are left with cosine of theta over sine theta, and cosine over sine is tangent, right? So we can look over at our quotient formulas. We highlighted that tangent was sine over cosine. Cotangent is cosine over sine. So I can get this down to a single expression of cotan theta. And of course, if we get it down to a single expression, that's really our goal. So from there, we'll say that we're done. So that's 32. So maybe 34. If I go through 34, we've got 1 over 1 plus tan squared, or tan squared x plus 1 in our denominator. Again, that makes me think of our Pythagorean identities, so let's go over and take a look. I've got, actually 1 plus tan squared is one of my Pythagorean identities. So 1 plus tan squared is equal to secant squared. So I'm going to use that substitution here, and instead of 1 plus tan squared, I'm going to write secant squared. And like we talked about in the previous question, right up, where was that? We talked, here and here. So 1 over secant squared is equal to cosine squared. Sorry, 1 over secant squared would be equal to cosine squared. So I'm going to go ahead and make that substitution here. Cosine squared over 1. Of course, that's just cosine squared. Oop. Sorry. That's just equal to cosine squared of x. So that, again, is a simplified version of that expression. Now, without an answer bank in front of you, you might say, is cosine squared x enough? Could I change that to 1 minus sine squared? Could I change it to 1 over secant squared? Typically, you know that you're done when your expression is, especially nothing in the denominator, it's one single trig expression. That's typically going to be when you consider yourself done. So moving on, we can look at 36. 36 is tan squared over secant squared. And we have thetas here over. So again, changing things to sine and cosine is going to be helpful. I'll spread these out just to make looking at it a little bit easier. So I've got tan squared theta over 1 times 1 over secant squared theta. And I'll change tan to sine over cosine. And then secant, we know is, if we move that up into the numerator, that's cosine. So I've got cosine squared, cosine squared theta over 1. So now I should be able to cancel out my cosine in the numerator with the cosine in the denominator, and I'm just left with sine squared. So that would be where I would end this. Sine squared theta. So that was for 36. So you can see that a lot of these just simplify down to one expression. So I'll keep going here for 38. That is cotan pi over 2 minus x times cosine of x. Now there are some other identities that are essentially, here, I'll pull them up so then we can talk about them. Our cofunction formulas up here. So cofunction formulas, as a really quick reminder, are formulas that allow us to understand that a trig function is just a shifted version of another trig function, right? When you take sine and you move it 90 degrees, you end up with cosine. These formulas formalize that and extend it to all of the trig functions that it applies to. So, if you want a more detailed explanation than that of what a cofunction formula does, you should look that up separately. So for us, though, I've got cotan pi over 2 minus x. Now, if I look up here, cotan pi over 2 minus x, that is the same thing as tangent. So this is telling us that cotangent is a 90-degree shift of tangent. So I can go ahead and make that substitution here, and that means that instead of cotan pi over 2 minus x, that's just going to be tan x, and then times cosine of x. Now I know that tangent is sine over cosine, and then I know that I've got cosine up here already, which means my cosines are going to cancel, and you're just left with sine x. So we should be able to use that cofunction formula to simplify. And again, refer to these when you're first getting used to doing problems like this. All right, might as well just go through and finish. So I'm just going to move these down. So I'm going to do 40 and 42. All right, and I'll just pause for a sec. So we'll do these last three, 40, 42, and 44. So 40 cosine of t and 1 plus tan squared of t. Now that 1 plus tan squared makes me think of my Pythagorean identities over here. And it looks like 1 plus tan squared is equal to secant squared. So for 40, I'm going to take cosine of t, and then 1 plus tan squared is the same thing as secant squared of t. Now secant is 1 over cosine, I know that, so I'm going to make that substitution, cosine of t times 1 over cosine squared of t. Now I've got 1 cosine in the numerator, 2 in the denominator, which means this should simplify out to 1 over cosine of t. Now I know I changed from secant to cosine, but I'm going to go ahead and change back because I would like my final answer to just be, one expression in the numerator. So instead of cosine t over 1, I'm just going to make that secant t over 1. Sorry, I think I said cosine t over 1. So 1 over cosine t is equal to secant of t. So we'll just go ahead and leave it like that. For 42, we've got cosecant of phi times tan of phi plus secant of phi. So looking at this one, first instinct is to change again to sines and cosines, but I also want to simplify this left part here, this cosecant phi tan phi. So I'm going to try and see what I can do to simplify that. So cosecant is 1 over sine. We know tangent is sine over cosine. And then secant, I'll go ahead and just do it, 1 over cosine phi for now. So the sine in the numerator and the denominator can cancel out, so I end up with 1 over cosine of phi plus 1 over cosine of phi. So I actually have two of the same expression. Now, 1 over cosine is secant, so I'm just going to go ahead and make these secant plus secant. Now there's 2 of them, right? So this should be 2 secant of phi. All right, last one, we'll do sine of theta, secant of theta, plus cosine of theta, cosecant of theta. So again, switch these to sines and cosines, it's going to make it easiest for you. So sine of theta times 1 over cosine of theta plus cosine of theta times 1 over sine of theta. So this is sine over cosine. Remember that sine over cosine is tangent, so I've got that highlighted over here on the right side already, but I'll just go ahead and do it again. Tangent is sine over cosine, so I'll make this tan theta, and cosine over sine is the one right below that, so that's cotangent. And once you have tangent plus cotangent, you can't really do anything else, so that's going to be how you finish up there. And you've got it down to single expressions.